Okay, today we are going to look at lesson 22 from Math UC Algebra 1, and we are factoring again, but this time with a coefficient. And what that means is we're going to have a number in front of that x squared that we weren't having before. Let's review. So this one is 1 like we did last week, x squared plus 14x plus 49. And when I said we need to factor this, we're looking for two factors, two things that we can multiply together that will give us this trinomial. And so the first thing we start with is we know that we need two factors. So I'm putting parentheses because I'm going to put my factors inside of here. I have an x squared, a 14x, and a 49. That x squared are going to be my first. When I FOIL, those are my first two terms, and they multiply together to be x squared. There's no number in front of it. So the only way that I can get x squared is an x times an x. Okay, my 14x comes from my outside and my inside terms. So I'm going to be needing to add together this x with whatever's over here and this x times whatever's right here. That's going to give me my 14x. So what goes in these last two spots? Well, my 49 is from my last two. So what multiplies together to give me 49? I think there's only one choice. I think that's 7 times 7. So if I put a 7 here and a 7 here, what would that do to my outside and my inside? Well, a 7 over here on the end would be 7 times x, and then a 7 in the middle would be a 7 times x. 7 times x plus 7 times x is going to give me my 14. I was saying plus, all of these are plus, so we will add them together inside our factors. So now we just need to check. I'm going to pull up a different color so that we can show you. So our first terms would be our x times our x. That's not much of a different color, but that's x squared. Our outside one right here is going to be x times 7. So 7x. Our inside term is 7 times x. And our last terms is 7 times 7. And then we just add all of these things together. So we have x squared. 7x plus 7x is a 14x plus 49. And that is indeed what we started with. So we know that we factored it correctly. So again, just to write it out a little bit neater over here, it is x plus 7 times x plus 7. So that is how we factor this polynomial. All right, so that's what we did last week. One of our steps when we were going through it says, well, we had no number in front of x squared, or you could say that it was an understood 1. So we don't have to have a number in front of our x's at the beginning, because right here in our first terms, x times x, or 1x times 1x, is just 1x squared. But what if we do have a coefficient in front of x squared? So we're going to look at this one, 3x squared plus 7x plus 2. I'm going to switch over to showing it with the algebra tiles like we were doing last week, so we can picture what it looks like. So here is 3x squared, 7x's, and 2 more. And we have to arrange these into a rectangle. And right now they're not, because I got some spaces over here. And also, we can't put these ones across the x like this because we don't know how long the x is. So how can I rearrange these to make a rectangle? If you want to pause, if you're looking at this video and you have your algebra tiles and you want to pause so that you can see how to do it, you can. I am going to start rearranging them how I think they should go. If I'm looking at my factors, before we would have like 1x here, and then we would have some green x's. I'm sorry, this is an x squared. We would have 1x squared here, and then we would have some green x's. Because remember, we usually have like x plus something, and down this side, it would be x plus something. Well, on this side, we do have my x plus 2, but across here, we just have 3 x's. We probably want another number here. So I'm going to take this one right here, and I'm going to rotate it, and I'm going to move it, hopefully, right up here next to my x squared. Now, you maybe are seeing it, that these two will fit right here. So I'm going to move those two. I'm going to try to move them at once, all at one time. Takes a little longer on the computer than you're hopefully working with actual algebra tiles. And now I have made a rectangle with 3x squared, 7x, and 2. So across here, I have an x, an x, and an x. So across the top, I have 3 x's plus this one length over here. And down the side, I have 1x plus 2 more. So that's how I have factored it. So we started with 3x squared plus 7x plus 2, and we factored it into 3x plus 1 and x plus 2. So let's see how we're going to do that on paper. Here it is again. We still have an x squared, so we know that the power is 2, and that's going to require 2 sets of parentheses because there are 2 factors. We also only have plus signs, so that's nice. We don't have to work with negatives yet. So I can put the plus in the middle of each of these parentheses. However, I do have that coefficient in front of x squared. So now I have to account for factors of 3 and factors of 2 when I get my ones in the middle, my outside and my inside, to add up to 7x. So one way you can think about it is if you need to list them down here. So 3x squared. 3 only has one set of factors. It will be 3 and 1. And I'm going to put the x's with it to kind of help me keep track because it's 3x squared. So I'll be multiplying a 3x times a 1x to get me 3x squared. And then I need to think of factors of 2. Well, factors of 2 are, again, just one set, 2 and 1. But I can arrange these in different ways. So my outside and my inside could be these multiplied together and then these multiplied together, or I could have these two multiplied and these two multiplied. So if I do the blue, if I do 3x times 2, I get 6x. And if I do 1x times 1, I get 1x. So when I add that set together, I get the 7x. What if I had done it the other way? The pink one, 3x times 1 would have been 3x, and 1x times 2 would have been 2x. That would have added up to give me the 5x. But what are we looking for? We're looking for the 7x. So we're going to go back to the blue. So I know that I want 3x multiplied by 2. I'm just going to put my x's in here, my 3x and my 1x. Now, if I want the 3x multiplied by the 2, do I put it here with the 3x or do I put it over here? Well, we have to think about our outsides get multiplied and our insides get multiplied. So when we're looking at which ones we want to multiply together, remember that it's not the same one that's in the parentheses with it. So I want to put the 2 over here. And then I want to put the x with the 1, so that will go right here. So again, this drawing up here is just shown right here. I have 2 ways to write the 3x and 1x and the 2 and the 1. And then you just guess and check. The more times you practice with this, the easier it will get that you might be able to just write them down and be like, oh, they pair this way, and so I put them in here. But at the beginning, if you need to write out this one and then kind of, draw your lines for foiling it and figure out which one works, that's fine. You're going to take a little while to get used to this. So I don't want you to think that you should be able to see it easily. It's going to take some practice, and it might take a little more paper than you are used to writing down. But just keep with it. And as you do this more, I think you'll be able to see it get easier. Okay, there is a picture of it, but we did it with the algebra tiles, so we don't really need that picture. Let's move on to another one. 2x squared plus 15x plus 7. So we see this 2 in front of the x squared. So we know that factors of 2 are just 2 and 1. So we'll have a 2x and a 1x. And then the 7, oh, we got lucky here. There's only one set of factors for 7, 7 and 1. But how do we pair them up? I'm going to write my factors, my parentheses here. I know that I can put the 2x and the 1x in, and then I'll just have to decide, oh, that was a 1, right? 7 times 1. I can put my 2x and my 1x in, and I see that it's all positive, so I'm not working with negatives yet. I keep saying yet. Aren't you excited that we'll get there soon? And now I just need to decide, do I put the 7 here or do I put the 1 here? So let's look at our outside and inside. This is what we need to add them up to be. So if I'm multiplying the outside and the inside, if I put the 7 here, it'll be 7x times, or I'm sorry, 7x plus 2 times 1. So 7 plus 2 is going to be 9. That's not big enough. Usually when I see a big number here, I'm thinking, okay, I may want to be multiplying the biggest numbers and the factors together. So if I put the 7 here, I would be multiplying 2x times 7. That would give me 14x. And then I just need that 1 right here to be one more x to give me 15. So again, I want to maybe retrace. I'm going to put the 2 times the 7. And then I'll put the 1 right here. So I'm just going to double check, make sure I did it all right. My first is 2x times x, which is 2x squared. My outside is the 2x times the 7. My inside is the 1 times x. My last is 1 times 7. When I add them all up, I do indeed get 2x squared plus 15x plus 7. So I did it correctly. Here we go again. We have 5x squared plus 17x plus 6. So 5x squared, I only know of one factor to get 5. That's 5 and 1. But 6, I'm going to have 2 choices. I'm going to write them over here. I don't know if that's going to help or not. I have 6 times 1, or I have 3 times 2. So let me break out my different colors. I have lots of choices at this point. I can multiply the 5 times 6 and the x times 1. Oh, it disappeared on the end of the page here. So I'm going to try that again. 5 times 6 and the x times 1. So 5x times 6 would be 30x, and then x times 1 would be x. So I have that choice. Break out a different color. I could do it in the other way. So I could do the 5x times the 1 and the 6 times the x. So that would be 5x plus 6x. Or I could do 5 times 3 and 1 times 2. So 5x times 3 is 15x, and then an x times 2. Or I have one more choice. I could do it the other way of that green one. So I could do the 5x times the 2 and the x times the 3. So 5x times 2 is 10x, and the x times 3 is 3x. So maybe you need a little bit more writing out than this. Let me rewrite what I was doing. So this orange one, I would put the 5x here and the x here, and then I would multiply the 5 times the 2 and the x times the 3. So that's this one. And my middle term, that's all I'm really looking at right now. My middle term would be that 13x. And that's not 17, so that's not what I'm going for. I'm going to do the blue one up at the top. So we did 5x and x, and I multiplied the 5 times the 6, and then I had a 1 right here. So when I did this and I multiplied the outside and the inside terms, I got 30x plus 1x, so I got 31x. So that's not what we're looking for. Now the pink one, let me write that one out. So if you notice, in all of these, I have the 5x right here, but I'm just switching up where I put the other terms. So in this one, instead of multiplying the 5 times the 6, I did the 5 times the 1, and then I put the 6 right here. So my outside term was 5x and my inside term was 6x. So 5x plus 6x is 11x. And that's not right. And now you see why I did it in the order I did. So my last one, I can put my 5x and my x in the same spot. And then I'm going to switch the 3 and the 2 right here. So if I put the 2 here and the 3 here, my outside is 3 times 5x. So that was the 15. And my inside is 2x. 15x plus 2x is 17x. So I'm just looking at my outside, my inside terms, because I pulled the factors for the first terms and I pulled the right factors for the last terms. So I'm really just looking at what can I get the middle term to be correct, that outside and inside one. And it is 17x, so it's this green one. So maybe I need to rewrite it right here just to say this is the one that I chose based on having to list them all out and just multiplying them out and seeing which one worked. Again, if you're ahead and you're thinking right and you just want to write them like this and maybe draw some arrows or this, or if you need to write the whole factoring out every time to figure out which one it is, you'll get better at it as you practice. So don't be afraid that if you have to write out all the choices, that's fine. That will get you there. All right, and we have one more here. Remember, you can always take out a factor that is in front of each part of the polynomial. So right here, we have 2x squared plus 6x plus 4. And that looks like, oh man, we're going to have to do all these choices again. Yes, you can. Or there's a 2 here, there's a 6 here, and there's a 4 here. Do those have a factor that all of them have in common? Hopefully you're saying yes. And it's a 2. So if I take a 2 out of all of these, what am I left with? If I take a 2 out of 2x squared, I'm left with x squared. If I take a 2 out of 6x, I'm left with 3x. If I take a 2 out of 4, I'm left with 2. So this is a little bit easier to factor because I don't have to think about the different x's in front. So I know I have x squared. I just put an x in both of them. They're all positive, so I'm going to be adding. Now I want factors of 2, and there's only one choice, that add up to 3. Well, 2 and 1 multiply together to be 2, and they add up to be 3. So I'm done. Let me show you what it would have looked like if you had not taken out that factor first. And when you're checking your homework against the book, it's not going to give you the same answer. So this is going to be the correct answer, but let me show you what you would get over here and why it will look like you didn't quite get it right in the book. And that's true because you didn't fully factor it if you don't take out that 2. So here I would say, okay, I need a 2x and I need an x. And now I need factors of 4 where I'm going to be multiplying it and it's going to add up to 6. So I could do 2 and 2, and that would give me 2x times 2 would be 4x, and then 2 times x would be 6. Yeah, that works, right? Okay. Questioning myself. Let me double check. Okay, my outside is going to be 4x and my inside is going to be 2x, and that does indeed add up to 6x. So, okay, so this is what it would look like, but this isn't the same as over here. Well, why isn't it? Because on this factor right here, you still have a 2 that you can take out of both parts of it. So if you don't see it at first, then you have to see it right here, because leaving it in this form is not all the way factored. And that's not what we want. That's not where we want you to stop. So if you don't take it out at first and you factor like this, that's okay. But you have to see that this factor can be pulled. They can pull out that 2. So I don't have to pull it out of all of the factors. I just have to pull it out of this one. but everything within the factor has to have something to factor out. So if I take a 2 out, then this right here just becomes x, and then this right here just becomes 1. Now I said I don't have to pull it out of both factors. So now it looks the same. I mean, these are in a different order, but the whole thing is multiplied together. And our commutative property tells us we can multiply in any order if it's all multiplied. Let me just go back and touch on this just a little bit. I said we don't have to pull it out of this factor. Think about if you had the number 20 and you're factoring it. You're going to say, okay, well, it's 2 times 10. So that's kind of like this right here. This is maybe our 2 and this is our 10. And then I say, but 10 isn't factored all the way. And you say, oh, you're right. I can factor 10 again as 2 times 5. So I took this one and I factored it again. I pulled out this 2 so that I could have what was left. Okay, so that's why you don't have to pull a 2 out of all of it, just out of one factor. It's just like this factor tree. Okay. In the past, I have tried to teach this bottoms up method. I've seen it from the kids that I used to tutor from Lindale, but I didn't learn it as a student. If you want to look at this, it's kind of cool, but honestly, I feel like it's not, I don't know. If you like it, anyway, I'm not going to teach it. So if you want to look at what this is, I think it's written out pretty well. You could even, you could probably YouTube search a bottoms up method for factoring, but I don't want to specifically teach it because I don't think it's the best way. It's cool if you remember all of it, but I feel like there's so many parts that you're just remembering steps, but you're not really understanding what it's doing. So if you want to look at it and you get it and you want to use it, that's fine. It's another method, but I don't want to teach it. So hopefully you've learned a little bit more about factoring, and good luck on your practicing. And remember that going slow is okay. These are going to take a little while. They're going to take some time. So don't save it all for the last day.